Okay, everyone. This is the third video I promised you, and I think this will be the last. I am starting to feel under the weather again, but I will say this. This video is probably the most important of three, and I'll make sure to point to this video before you watch the previous two videos when I post them, okay? In Google Classroom, that is. But anyways, let's get started here. Okay, look at problem 26. This, I hope you will totally understand. Again, I'm going to do a quick sketch, right? That's always step one. Do a quick sketch, see what you're looking at, what you're looking for. They tell me the mean is 50. I know that goes right in the center of my graph. They tell me the standard deviation is 7 here. So again, I could start counting 57, counting by 7, 64, 71. Correct? If I count this 7 backwards, then from the mean, that is, that would be 43, 36, and 29. Now, to answer this question, they want to know what percent of the scores fall between 36 and 64. So since this is a pretty quick answer, let's make sure we understand one thing for sure. If we go again, one standard deviation each way, right in here, that would be 68% of everybody, of all the scores being evaluated here, right? 68% of them. Okay, all the scores are going to be right there. In our case, they were asking for 36 here to 64 there. Well, isn't that 2 standard deviations each way? And hopefully you understand, including the middle that I colored in red, the 68% in the middle, if I include that plus the extra 2 intervals on each side, that's a total of 95% of all scores. And so that was our answer. We know 95% roughly of all scores are going to fall between 36 to 64. If they would have asked us 29 to 71, notice we would go out 3 standard deviations from the mean each way. And according to the empirical rule, that would have been 99.7% again, which is basically everything except 0.3%. Almost everybody, in other words, should be within 3 standard deviations of the mean when you have a normal distribution. Okay, so pause the video if you need to. Finally, guys, let's do this one. Again, 27 is the problem here. And we know we're doing a standardized test. It's a normal distribution. Let's get our sketch here. Doesn't have to be perfect. We know the mean is 64.3. Let's put that right in the middle. We know the standard deviation, 5.4, is right there. Let's go ahead and actually, let's just pretend, and I'm going to assume that these values are not perfect whole number intervals, right? It's a regular normal curve problem. Let's go ahead and do the z-scores for each one. Does everyone, by the way, agree somewhere over here is my 61.6, right? It's below the mean of 64.3. Let's find its z-score in purple. I know the z-score is going to be the raw score minus the actual mean, 64.3, divided by 5.4, right? 61.6 minus 64.3 divided by 54. So if we go ahead and subtract those two, we will get negative 2.7 dividing by that 5.4, guys. Is going to be negative 0.5. So see, we got a z-score that wasn't exactly 1 or negative 1, something simple like that. So I'm glad that that happened. Now let's go ahead and do the z-score in green for the 75.1. By the way, 75.1 would definitely be above the mean, right? It'll be up here somewhere. Actually, probably a little bit higher. But let's see here. I know the z-score for 75.1 will be 75.1 minus our mean divided by standard deviation. We get 10.8 divided by 5.4 is 2. So it is a nice whole number 2. But anyways, let's go along with it. Now that we have the z-scores, we now can go to the z-table and find our actual percent value, correct? Forget about this time the empirical rule. We're actually going to do real stats calculations here using the table, okay? And so let's start with the 0.5, negative 0.5. Here it is right here. The first value, do you agree, is negative 0.50, right? If we went to the second one, that would have been negative 0.51. The third one here would have been negative 0.52. Again, I taught that to you in class. Hopefully you got a hold of it. But we just need the first one, right? And if it's okay, guys, I'm going to just use 0.308. Although your teacher next year probably will include all 5 digits. So we know that this z-score right here is 0.308, correct? Yes, it is. Boom. Okay, so now let's again now look up positive 2 z-score. And as you can see here, right here, the first value is positive 2.00. And again, I'm just going to use the first 3 digits, 0.977. Okay? So we know that this one came out to be 0.977. Now, the question is, what percent of the scores fell between the two? So guys, we want everybody that's between these two scores. How do I figure that out again? Well, I'm going to take the score for 75.1, which is 0.977. I'm going to go ahead and subtract this part here, which came from the 61.6, the lower end of it, which again was 0.308. And hopefully you agree that if I take everything in red, right, and I take away that piece at the end that I just circled in purple, I'm going to get what I have in the middle here, which is what I want in red and blue between those two values, 75.1 and 61.6. So let's see what we get. 17 minus 8 is 9, 6. So unless I made a mistake, guys, it's 0.669. And 0.669, if I move the decimal twice, becomes 66.9%. So what we just figured out, guys, is everything right in there between 61.6 and 75.1 would be 66.9% of all the scores. Okay, so guys, that ends this video. Okay, the important thing is, if you have any questions, please ask me in class. I apologize again. I'm not feeling well these last couple days. I'm giving it the best I got. But mentally, I'm not as clear as I usually am. And, but anyways, I will see you in class tomorrow. Sick or not, I will see you in class tomorrow. That is a promise. If you have any questions, please come by and ask. Okay? I'll see you in class.